Hi everyone, welcome to Integral Calculus. Today we explore lesson 6.5, average values. Number one, the idea. So if we have a function fx and this function go from A to B, how do we find the average value of the function from A to B? That is not the same as the average value of a bunch of number. Because the function is continuous, we got to divide the interval. From A to B, we can do a divide into n interval. So each interval gonna have a width. That is delta x is b minus a over n. And we can take the value of x of 1. Because the value of x1 is exactly fx1. Similarly, we can take value of x sub 2. And this gives us fx sub 2. So on and so forth all the way to x sub n. The average value would be of n values is of course 1 over n fx1 plus fx2 plus dot 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 plus fxn. Okay, we can replace n by b minus a over delta x. And so this would be, well, 1 over b minus a over delta x multiplied by fx1, fx2, fx sub n. Next step is to simplify this. So this is the same as delta x over b minus a. I'm gonna write out it's gonna be a 1 over b minus a, and I put the delta x back there. This one is the same as the summation of fxi going from I equal 1 to n multiply to delta x. Average value of n numbers. Well, we want the average values of the function. Now, average value of f is the same as f avg, average. To do this, we got to take the limit as n go to infinity. Because we got to count all the points from A to B. So this be a limit n go to infinity. 1 over b minus a summation I equal 1 to n fxi delta x. Well, this is exactly the limit of the Riemann sum, and thus it is the integral from A to B. We can take out the 1 over b minus a, 1 over b minus a fx dx. Wow, nice. Let's take a look at applications. Example, how to apply this formula. First application or example is find the average value of fx equals square root x on the interval 1 to 4, and the value C on the same interval, so that FC equal F average. Okay, so first let's take care of the average value here. F average is 1 over B minus A, so 4 minus 1, integral 1 to 4 root x dx, 1 over 3. So this one is the 1 over 2 plus 1 is 3 over 2, so 2 over 3 x 3 over 2, evaluate from 1 to 4, 2 over 9, 4 3 over 2, minus 1 3 over 2. So have a 2 over 9 multiply to A minus 1. And this gives us 14 over 9. So this is the average value. We can actually find a number C, so that FC equal F average. FC equal F average. So root of C equal 14 over 9, which means C is 14 over 9 square, and that would be 196 over 81, or approximately 2.42. What is cool about this one is that we can sketch out the graph so that you can get a better visual of what is going on. X, Y, right? That is the square root x there. Going from 1 to 4. Okay. So somewhere right here is the 2.42. Or 196 over 81. And if you take a look, you will see that if we use it to get a rectangle, then the area of this rectangle is exactly the same as the area under the curve from 1 to 4. Notice that (196 over 81 multiplied to 4 minus 1). That is the area of the rectangle. It's exactly the area of the curve from 1 to 4. And this is, well, in general, it's FC times B minus A equal the integral from A to B fx dx. We call this the mean value theorem for integral. The function ft equal 48 plus 14 sine of pi t over 12 models the temperature in Fahrenheit in November for a Northern California region after 9 a.m. Find the average temperature of that region from 9 a.m. to 9 p.m. Round off the answer to the nearest integer. Before we do this problem, 9 a.m. is the same as 0 hour. 9 p.m. would be 12 hours from 9 a.m. Now we can set up the integral. F average is 1 over b minus a, so 12 minus 0. Integral from a to b, 0 to 12. ft dt, 48 plus 14 sine of pi t over 12 dt. That's 1 over 12. And then we can take the antiderivative right away. 48t plus 14 derivative side negative cosine pi t over 12. And then we got to multiply by the u sub because we let u to be pi t over 12. So I mean du is pi over 12 dt. And thus we have to multiply by 12 over pi du. Or in this case, 12 over pi. And evaluate this one from 0 to 12. Okay. I'm gonna do a little distribute and simplify here. So I can distribute the 112 inside, and that gives us a 40 minus 14 over pi cosine of pi t over 12. Yay! 0 to 12. Plug in 12, we get 48 minus, okay, 14 over pi. Cosine of 1 is cosine pi negative 1. Okay. Plug in 0, we have 0 minus 14 over pi, and then cosine of 0 is 1. So what we have is 48 plus 14 over pi plus 14 over pi. 48 plus 28 over pi. This is approximately 57. Example 3. The linear density in a rod 10 meter long is 10 over square root x plus 12 kilogram per meter, where x is measured in meters from one end of the rod. Find the average density of the rod. Let's take a look. F average is 1 over b minus a. Well, one end of the rod is 0, the other end is 10. So 10 minus 0, integral from 0 to 10 of the density is the 10 over root x plus 12 dx. Yay! We can factor the 10 and then get rid of the 1 over 10. So there's the integral 1 over root x plus 12 dx 0 to 10. Can do a quick u sub here. U is equal to x plus 12 du is dx. Then at the same time, I'm going to change the limit here. Upper limit is 10 plus 12 is 22. Lower limit is 12. Yay! And then with the u sub, then we're going to get a 12 to 22. 1 over root u du. And this gives us the u to the negative 1 over 2. So plus 1 is 1 over 2. And we are 2 root u. Evaluate from 12 to 22. So we have 2 root of 22 minus root 12. Yay, and that is the average density of the rod. Convert it into a decimal, and that would be approximately 2.4526. The unit for density is kilogram per meter. Thank you for watching. I hope you found the content useful. Please like and subscribe to help the channel grow. I'll see you in the next video.